Welcome to High-Tech Heroes, the program that takes you behind the scenes of today's high-tech industries, where you can meet the people and examine the ideas creating tomorrow's technology. And now, coming to you from the Foothill Studios at Foothill College and Cable Access Los Altos, high atop the mountains overlooking Silicon Valley, here is your host, Sherwin Gooch.
Hello, I'm Sherwin Gooch. Welcome to High-Tech Heroes. This week, my guest is a technologist who's best known as a Unix guru and a designer of computer-aided software engineering tools. But he's also a sailor, a snorkeling enthusiast, a musician, a hang glider pilot, a model rocketeer, home radio astronomer, microscopist, photographer, holographer, inventor, and father and creator of low-budget, high-tech toys for children of all ages. And so I'd like to welcome a latter-day Mr. Wizard, Simon Field, to our program. Hello, Simon. And welcome to High-Tech Heroes.
Happy to be here.
Feel free to call me Sherwin. Can I call you Simon?
Certainly.
Great. Well, where did you grow up, Simon?
San Diego and Claremont, down in Southern California.
Southern California. And where did you go to school?
San Diego State University and UCSD.
What did you study in school?
Biochemistry and computer science. It was a double major. So they're both at the same time.
So you weren't seduced by computers like so many of my friends who started out in computers and another science?
No, they're pretty much simultaneous.
Oh, that's good, I guess. And what was like your first project? Do you have a project you did in high school or before?
Yeah, several projects in high school. I was doing model rocketry and stuff. Built a car that ran on smog. You know, the normal kind of things that high school students do.
A car that ran on smog?
Yeah. I was funding it by asking people to donate 50 cents every time they asked me to explain how the thing worked. So, you know, I eventually got enough money together.
So a lot of people were curious as to how this worked.
Oh, for sure. It was very smoggy in Southern California, so there's a lot of
fuel
fuel
and
and
stuff.
stuff.
I think.
More so then than now. But,
So how did this thing work?
Well, you got 50 cents.
Well, was it an internal combustion engine, or was it?
No. It took smog in, put smog out.
Reprocessed the smog.
Yeah.
It's going to cost me 50 cents to find out, huh?
Sure.
Well, I guess we're kind of low budget,
wheels.
but we can afford 50 cents here.
Oh, okay.
Well, those are nickels there. Here you go. Okay, there's 50 cents. Now, how did this thing work?
Okay. Well, it was a sailboat on wheels.
Oh.
Yeah.
So you tricked me. You tricked all these people, and they didn't take their money back?
Actually, when they saw the plans and things, they were really intrigued. It was everybody loved the idea. Bankers loved the idea. The policeman who gave us the ticket for speeding on it loved the idea. You know, it was.
You got a ticket for speeding?
Yeah, we sort of orchestrated that.
So this worked very well, I guess.
Well, it was a 35-mile-an-hour zone in the street.
Did you have any problems with it?
We had one. I remember when we were once moving it from one place to another, there wasn't enough wind to actually sail it, so we were pushing it down the street. There were three of us pushing it, and all of a sudden the thing stopped. And we checked the wheels, checked one wheel and then the other wheel, and so they were all spinning and working fine. So we all three got back and pushed really hard, and both the front wheels came off the ground. Okay? And so it's sitting here on just one back wheel. Couldn't figure this out. Okay? We pushed harder. The back wheel came up. Okay? They're all spinning. The whole thing was off the ground. We finally looked up, and the mast had caught in the power lines.
And this was all the science geniuses from your school?
Of course.
Oh, it really puzzled them. So, I guess also, I understand you built some lasers in high school, is that right?
Mm-hmm. Built them out of plans from Scientific American's amateur scientists. So we had the organic dye laser that was tunable through various wavelengths and so on, and the ultraviolet laser that ran on low-pressure nitrogen.
Right.
So that was a nice one. It didn't need any mirrors or anything, so it was a very simple mechanism, and put out ultraviolet pulses that we used to
So they were ultraviolet, so you couldn't see these, right?
No. One of the ways we tested it was we put some drops of gasoline in a mason jar, closed the jar lid real tight, shook it up, stuck it out in the middle of the street, and the ultraviolet pulses were at the right wavelength for initiating the reaction between gasoline and air.
Let me see if I understand this. What you're telling me is that accidentally this dye laser that you had, was it a nitrogen laser? Okay, nitrogen laser that you had the right, one of the lines, radiation lines, was the same as an absorption line for common gasoline.
Gasoline and air mixture, right.
And so you were able to initiate a reaction?
Yeah.
It's like an explosion,
blew up. Yeah, we only found the lid of the mason jar. We didn't find any of the glass shrapnel anywhere.
And so that's very interesting. Don't try this at home, kids. And what else did you build? You work, I guess, on kites, right?
Yeah. In fact, I brought in a camera here for putting up in a kite and taking aerial photographs of yourself. I also brought in a model of its trigger mechanism here. This is a trombone-shaped piece with a loop here and 2 loops.
Now this is a model.
This is, yeah. So the actual one is back here hanging on a string.
So I don't know. This is very small.
Yeah.
I don't know if we can see that or not.
So this is
a large
So this
model,
goes through here like this.
So now the string is here.
Right. And this is along the string. And you put a piece of paper on the string, and the wind blows it up and pushes this. And if there's a weight hanging
Okay, so say I have this hanging here. Okay.
Then as the...
Oh, wait, now I've got a piece of paper blowing up the string of the kite. It comes up here, hits this,
and drops the weight.
Yeah,
now,
we used to drop parachutes by just flicking the string, but this is a mechanism that works better, I guess.
If there's a weight like this hanging from...
Okay, now so this is just a camera.
Right, this is a very cheap camera. The string is attached to its shutter release. And
how cheap is this camera?
About $15. Something so that if the kite falls down and the camera breaks, you're not heartbroken.
Okay. So this is low budget, high tech.
So the message comes up the string, drops the trigger, and this little fishing weight here drops and takes a picture.
Oh, well, you developed that after the show. Yeah, well, I'd like to be able to have aerial photography like that. I tried to do it with model rockets, and they kept getting stuck in the trees and ruining the film. I understand you're also a home radio telescope enthusiast.
Yeah, my daughter and I built a radio telescope.
This is not something you build every day. I mean, how do you build a radio telescope
it's not the
at
big
home?
dishes like professionals use. This is about a 10-foot long antenna, a very highly directional antenna, like the ones that ham radio enthusiasts use. And it's made out of a 10-foot long piece of wood with some lateral pieces of wood like a ladder. And some aluminum tubing.
So this is just a directional antenna that looks like a normal TV antenna or something.
It looks,
a boom and a bunch of...
Well, they're not just bars, they're squares. And so it looks quite striking, actually. Okay, each of these squares of aluminum tubing goes smaller and smaller, 5% smaller as you get 8 of them in a row. Okay, and in fact, we had it out in the front yard when we were testing it, and big black cables coming back into the house into an FM radio, which was picking up these signals. And the neighbors thought that I was setting off electrical storms that had happened the next day because of this big gadget that was out in front.
So how does this work as a radio telescope? You point at the sky and...
Yeah, point to the sky and listen to static. And the volume of the static, certain stars produce a lot lot static.
And how do you point it? You just point it, or do you...
Well, this one, we aim at a certain angle, point it south and aim at a certain angle and let the rotation of the Earth do the sweep.
So the angle, so the declination you set and the...
Right.
What do you call it? Right ascension is just the Earth's rotation?
Right.
Okay.
And then there's a computer listening to how loud the noise is, and it draws a plot as you go past noisy stars and quiet stars and things. You see the plot. So
a fairly cheap way to build a radio telescope.
Yeah.
And I understand you're also a holographer, is that correct?
Yeah. We have one up here. It's a little hard to see in the camera here. This is one that my daughter actually did of a little vase. Yeah, we might be able to see it a little bit in there. Some fuzzy stuff back there.
See, I can't look at it on the monitor.
Yeah, there's a little spotted
You can just
vase.
barely
There
see
we
it on the
go.
monitor.
Yeah.
Can we rotate it side to side so they can get some 3D effect, or I guess not? It's fastened down.
Yeah, something like that. Yeah, you can see some of the 3D and a little shadow there.
Well,
anyway.
So this was a fairly cheap hologram to make?
Yeah, the plate costs the most money, but the laser light comes through the plate, hits something behind it, you know, the object that you're looking at behind it. The light then reflects off of that back onto the plate, and the two beams, the one coming into the plate and the one reflecting from behind, do the interference that makes the hologram. And so that you don't require any fancy lenses, you don't require any beam splitting mirrors or anything like that. It's a very simple apparatus.
Okay, well, while we're on the subject of optics, I understand that you built a microscope.
Yeah, this is a very special one. This is a model of van Leeuwenhoek's original microscope. His was actually about 2/3 this size, so you get the feeling, the idea that they're very small, the very original first microscope.
So now anybody could make this. It's just some pieces of brass and some screws?
Yeah, this is a very good lens out of a microscope objective, but otherwise it's all brass, hand threaded and tapped. So they're a set of screws here.
And how does this work?
This screw raises and lowers the object. This screw pivots so that the thing can be moved left and right. And this screw adjusts the focus. And this screw here allows the object, which is on this little pin here. This one has a little hole here so that I can put a drop of water and look at organisms.
Let me see how this works.
Certainly.
So now this is the focus right here. Okay, so now I should be able to hold this up here, put my finger here, and adjust the focus. Let's see, there's my fingernail. Yeah. Well, yeah, that works pretty well. You can see a little bit of my fingerprint. Okay. Well, that's pretty good. And I guess you also brought some electric fish and some, you're going to tell us how we can make recordings through a home microscope with your own VCR at home. And I guess we'll get to the electric fish as soon as we get back, right after this.
First call for help. How may I help you?
Are you looking for senior services, family counseling, or help in solving substance abuse or other problems?
There is an agency that's located right near you, the Bill Wilson Center.
Do you need an emergency food program? Do you need to find a first aid or CPR class?
Yes, the agency does offer low-cost services.
Maybe you'd like to help someone you work with or someone you love. When you don't know where to turn, there's United Way's First Call for Help.
Let me give you the agency's phone number. It's 408.
United Way's trained referral specialist will refer you to the most appropriate agency to meet your need.
If you need further assistance, please don't hesitate to give us a call.
It's free, it's confidential, and it's the most comprehensive list of services available. First Call for Help. United Way. It brings out the best in all of us.